Hello guys, hope you're doing well. In this video, we're gonna start one of the most important ideas in mathematics, the concept of a limit. So stay with me until the end of the video. Let's look at a numerical example. These numbers are getting closer and closer to 2. They're not exactly equal to 2. But as we continue the pattern, the numbers approach 2 more and more. In mathematics, we say the limit of this sequence is 2. This means the values approach 2 even if they may never become exactly 2. Okay? Now let's see how this idea appears in functions. So look at the function. F of x is equal x squared minus 1 divided by x minus 1. If we substitute x is equal 1, so the denominator becomes 0. So the function is not defined. But let's see what happens when x gets close to 1. For example, if x is equal 1.1, so f of x is about 2.1, and if x is equal 1.01, so f of x is about 2.01, and if x is equal 1.001, so f of x is about 2.001. And from the other side, if x is equal 0.9, so f of x is about 1.9. If x is equal 0.99, so f of x is about 1.99. So from the both sides, the values of the function are getting closer and closer to 2. Okay, so we say the limit of f of x as x approaches 1 is 2. Even though the function is not defined at x is equal 1, the values around it clearly approach 2. This is the key idea of a limit. A limit describes the value of a function approaches as the input gets closer and closer to a certain number. So whenever you heard the word limit, remember this simple idea. A limit tells us what value function is approaching, even it never actually reaches it. Okay guys, we want to understand the idea of a limit at a specific point. So look at this graph carefully. For example, this graph, and for example here is 1 and the y value is, for example, 2. So if we approach 1 from the right, for example here is 1.1, 1.001, here is 1.01, and here is 1.1. Okay, so the graph approaches 2 from below. Okay, for example here is 2.1, here is 2.01, and here is 2.001. Look at this graph again. We are here, okay? And x value is 1.1 and the y value is 2.001. So if we approaches 1 from the right, so the graph approaches 2 from the below, okay? And from the other side, if we approaches 1 from the left, the graph approaches 2 from above, okay? So if the graph is open itself, means like this, or the function has a hole there, the limit exists because the graph approaches the same value from both sides, okay? For example, if f of x is equal x plus 2, so we want to find the limit of f of x as x approaches to 1, we want to find. Okay, so let's see what happens when x gets close to 1. For example, if x is equal 1.1, so f of x is equal 1.1 plus 2 is equal 3.1. If x is equal 1.01, so f of x is equal 3.01. If x is equal 1.001, so f of x is equal 3.001. Okay, and from the other side, if x is equal 0.9, so f of x is equal 0.9 plus 2, 2.9. If x is equal 0.09, so f of x is equal, 0.99. So f of x is equal 2.99. And if x is equal 0.999, so f of x is equal 2.999. So we can see that the values of the function get closer and closer to 3. Okay, so the limit of f of x as x approaches to 1 is 3. Okay, let me give you another example. Consider this function f of x is equal x squared minus 4 divided by x minus 2. So if we substitute x is equal 2, so the denominator becomes 0. So the function is not defined at x is equal 2. So the limit of x squared minus 4 divided by x minus 2 as x approaches 2, let me simplify, is equal x approaches 2, we have x minus 2 times x plus 2 divided by x minus 2. So x minus 2 and x minus 2, they cancel out, and we have the limit of x plus 2 as x approaches 2. So this function behaves like x plus 2, and if x gets closer to, for example, if x is equal 1.9. So x plus 2 is equal 3.9, and if x is equal 1.99, so x plus 2 is equal 3.99. And from the other side, if x is equal 2.1, so x plus 2 is equal 4.1. And if x is equal 2.01, so x plus 2 is equal 4.01. So the limit of x plus 2 as x approaches 2 is equal 4. Even though the function is not defined at x is equal 2, the values around it approach 4. Okay? So I'll solve a lot of examples in the next videos. So don't miss it, and see you soon.